Welcome to online classes of Metallurgy and Material Sciences. Today we are going to discuss the further topics of Unit 2 of Metallurgy and Material Sciences. So let us see what are the topics which we are going to discuss in Unit 2. First topic in Unit 2 is fracture. In that we are going to discuss about ductile and brittle fractures, modes of fractures, ductile to brittle transition, and crack initiation and propagation of the cracks. The next topic is fatigue. So in fatigue we are going to discuss S by N curves, that is nothing but stress to number of cycles curve, structure of fatigue failure, fatigue crack propagation, effect of metallurgical variables on fatigue, means what are the various types of effects which we are going to discuss in this. So next is experimental determination of fatigue strength. So that is RR-Mori test, is the test which we are going to conduct on any material to identify how many number of cycles or how many number of stresses it can withstand. Next is creep strength, creep curve, creep deformation, creep test. So first of all let us start with fracture. So what is a fracture? So fracture is nothing but any material. First of all we have discussed in our first unit about plastic deformation. So similarly in fracture what happens means, whenever the stress strain curve we have seen that after yield point, when you keep on increasing the strain at some stress, so what happens means the material will break. So if it is a brittle material it will break instantly. If it is a ductile material it will undergo some plastic deformation, then it will break. So breaking of a specimen into two or more pieces is called as fracture. So it is happening because of what? It is happening because of external loads. So when you apply the external load, the material will break into two or more pieces. So first of all the fracture is divided into two types. One is fracture of ductile material, another is fracture of brittle materials. So for a fracture to happen, there are two steps to be taking place. First is crack initiation. For example, if you want to break a material, so first what you will do, for example, you take a steel rod. Okay, so if a steel rod, first when you are trying to extend, as we have seen in stress strain diagram, so after some point the rod will keep on start expanding. So at some point you can able to see some small crack. If you are not able to see this, let us take an example of your refill of your pen. So if you try to bend it, so when you bend it you can able to see a small necking, that is nothing but a small mark will be formed on the nib, at the bending point of the lead. So if you keep on doing that, at that point what happens means the refill will break. Okay, so for a fracture to happen, first stage is the crack should be initiated. So the another example I can give is, for example, on the tempered glass of your phone, if you see, if it is having a small crack at any point, okay, so that whole crack will be extending throughout your screen. Okay, so first initiation will be done with a small crack and that will be propagated next to next. What is propagation? Is nothing but it keeps on moving. Okay, it tries to move. So in crack what generally moves is, already we have discussed about the defects. So point defects, line defects, and that is nothing but slip. So these things are going to happen for the crack propagation. Once a crack is formed, so because of the crack, the dislocation which is happened, it will try to propagate, move forward in the easiest way. So whatever the weak points, whatever the weakest positions which are having in your screen or whatever may be the material, so it will try to transmit throughout the material and it will break into two pieces. So that will happen only under external load. If it is a ductile material, in that the material will first undergo plastic deformation, then it will break. Okay, so the example which I have given is, first example, refill. Refill is an example of ductile material. When you keep on applying the load, the material will first bend, then it will break. So another example I can give for ductile fracture is the sheet metal work which you are doing in your labs. So when you keep on hitting a steel, the steel will first bend. So once it bends, if you keep on hitting at the same position, a small crack will be initiated. After that crack, the material will be breaking into two pieces. So first in ductile material there will be first plastic deformation. After plastic deformation, the material will break into pieces. So whereas the best example for the brittle material is, one is glass, next is wood. If you are cutting a wood, in wood there will not be any plastic deformation. The wood will be undergo elastic deformation, or else it will be break into two pieces. For example, you might have seen a person who is cutting a tree into two pieces. The tree will not bend, it will not bend, and it will be in that place for a few times, then again it will not break. Okay. When you are keep on hitting it, it will just break into two pieces. So that is brittle. Okay. So the fracture is separation of a body into pieces due to stresses at a temperature below the melting point. So if it should happen below the melting point of the material. So what are the steps? Crack formation and propagation. So depending upon the ability of the material to undergo deformation before the fracture, the two fracture modes have been defined. So this is completely depending upon the deformation of the body during plasticity. So basing on the plasticity itself, the fracture has been divided into ductile and brittle. So ductile fracture is mostly metals will undergo ductile fractures. That too, it should not be too cold. For example, if you see a glass which is maintained at a -degrees temperature, so because of minus temperatures itself, the glass will have some crackings. Okay. If suddenly if you take ice water, if you are suddenly melting into some -degrees temperature, it will create, because of contraction, it will have some cracks. So next, extensive plastic deformation ahead of crack. In ductile material, what will happen is, before breaking into two pieces, the material will undergo a lot of plastic deformation. Okay, just like I have told the example of a sheet metal, when you are keep on hitting, it will completely undergo the plastic deformation first, then after only it will undergo the cracking. So in this, crack is stable resistance further extension unless applied stress is increased. So crack is stable means, once a crack is formed when you are bending a sheet, if you are keep on hitting it, once a crack is initiated, then until unless you apply the further stress, the crack will not propagate easily, because the material is ductile. That too, it has undergone plastic deformation. It will have some own dislocation density, because of which its hardness will be improved. So because of its hardness, again the cracks will not be easily initiated to propagate from one position to other position. Whereas in brittle materials like ceramics, ice, cold metals, so relatively little plastic deformation, it will undergo a small amount of plastic deformation, and the crack is unstable. We cannot once the crack is initiated, we cannot restrict the crack to stay at a position. Once it is initiated, it will just propagated. You might have seen on your tempered glass itself. Once one crack is formed, within 1-2 days you can observe n number of cracks to be formed on your screen. So the crack is unstable, propagates rapidly without increase in the applied stress. Even though you are not applied any stress on your phone, then also the cracks will be propagated. So the ductile fracture is preferable in most applications, because it will be related with the plastic deformation. So that will be mostly required. This is the reason why, even though the glass is brittle material, this is the reason, because we don't want the fracture to be brittle fracture, we always want a fracture to be ductile. This is the reason why automobile glasses, like the front glass of a driver will be made of, along with glass there will be addition of some plastic materials. You might have seen that. So once a car glass, when it gets cracked, it will be cracked for few days. It will not start to break whole glass at a time. Okay, until unless the damage is a huge damage, until unless the accident is a huge accident. So what they are doing in that glass is, in that glass, if you check, along with the glass there will be some amount of plastic layer in that glass. So that is the reason which helps to make the material from brittle to some amount of ductile fracture in that glass. Because if you use direct a glass, if some person who is walking on a road, if he comes and hits to the glass directly, so that glass will shatter like into pieces, and that pieces may go into the driver's eye. So to avoid that itself, that glass will be added with some amount of plastic, so that it can be made into a ductile fracture. I hope you have understand what is this. So next, how the ductile what is the difference between a ductile fracture and brittle fracture if you see. So if the material is too much of ductile, high ductile, so it will try to be attached with the material till the necking keeps on increasing, and at some point it will not be able to withstand the stresses at this point. So after this point it will break into two pieces. So this is plastic deformation. In this plastic deformation it will try to overcome a lot amount of stress here. So unless if it is a more ductile material, the most ductile materials will come like this. So it will be try to maintain the contact between the two materials because it is completely undergoing the plastic deformation like this. At some point it will not be able to maintain it, because of that it will break into two pieces. Okay. Now if the material is somewhat ductile, not too much ductile, not highly ductile, then it will try to maintain some distance, it will undergo some plastic deformation like this, because initially it was like this, so it has gone this plastic deformation, this curvature has formed. Again if you keep on increasing the stress, so it cannot able to withstand, then it will break into this. So there will be a zigzag type of material breaking will be happening if the material is moderate ductile nature. Okay. If it is purely ductile, the breaking will be like this. It will be purely split into two pieces, because in this there will not be any kind of plastic deformation. It will be just broke into two pieces when you apply the stress. Okay. So how neckings are going to happen in plastic deformation is, when you are applying the stresses, these are tensile stresses when you are applying them on a material. So first of all its thickness will be reduced. For example, you take a rod, okay, you are stretching the rod from two sides, the length of the rod will be increasing and the thickness of the rod will be decreasing. That thickness is nothing but the diameter of the rod will be decreasing, that is shown by this curvature. So it will first decrease. So when it decreases, because of the structure, already you have studied the crystal structure and the atoms will be there in the space lattice. When it is being enlarged, because of that enlargement, the atoms or the crystals in this will try to move forward. Because of that, there will be small micro cracks or the small amount of what we say defects, like small voids or something will be formed in it. So if you still keep on increasing the load, so these small gaps will all combine together, that is called as dislocation density. So its density will increase to some level, so where the crack will be formed like this. So again if you keep on increasing, so it will try to be like, again it will try to propagate till the edge of the material. So it will be till the edge of the material. If you still keep on increasing, then it will be broke into two pieces. This is one side it will undergo shearing, one side it will undergo fibrous type of material. So this is purely a fracture. If it is a ductile material, that is nothing but is a good ductile material, means like MS steel, mild steel, then this shape formed will be like cup and cone. One side it will be like a cup, other side it will be like a cone. So what are the steps that are going to be followed in ductile fracture are necking, micro crack formation, crack formation, that is from micro cracks all the cracks will combine together and they will all associated, and dislocation density will be improved. Once the dislocation density is improved, they will propagate and they will reach to the final destination like your edges. So once they reach the edges, so after reaching the edges, they will break into two pieces. That is, we call it as a fracture. Okay. So now if you see brittle fracture, there is no plastic deformation. Okay, and low energy absorption before failure. It will not keep any energy before undergoing failure. Okay, so once you give the energy, it will absorb the energy and it will break into two pieces. Okay, the crack propagation spontaneously and rapidly will happen. You can see with a glass. So once you hit a glass, the glass will break into just like that. It break into two pieces. Okay, I am saying two pieces means it will form more than two pieces. You cannot ask me, sir, will it exactly form two pieces? No, it basing upon your stress applied, it can shatter into a lot of pieces. So occurs perpendicular to the direction of the applied load. In which direction it will fail? It will fail in the direction of the perpendicular to the direction of the applied load. The crack propagation corresponds to a successive and repetitive breaking of atomic bond along the specific crystallographic plane. So we call that plane as cleavage, and this type of fractures are called as cleavage fractures. This type of fractures are generally found in BCC, body centered cubic structure, and hexagonal composite structures, but not in FCC. Okay, hexagonally closely packed structure, HCP. I have shown you this HCP also. In that there will be atoms arranged in type of a hexagon. Okay, so in hexagon also there will be three elements existing at the center of the atom. Okay, so this is hexagonally closely packed structure. So this is for brittle material, it will form like this. This is cup and cone structure. This is cup, this is cone. Okay, for the brittle material it will be almost like this. The fracture will be purely like this. Okay, so next in this there are intergranular and transgranular fractures. So what is intergranular, what is transgranular is nothing but intergranular is nothing but breaking the grain structures generally. So inter means separate. Okay, intra means from inside. Okay, so if you see this in intragranular or transgranular, the cracks will try to move along the grain boundaries. So whatever the boundaries you have, because boundaries are easily breakable, so the atom will try to propagate along the boundaries. Okay, so boundaries are the paths. Already they are having a path, they will pass through the paths. So after passing through the paths, the material will break into two pieces. Whereas in intergranular structure, what will happen is the material will break into two pieces. It will not pass through the boundaries, but whereas it will pass through the material structure. So while passing through, there are many n number of atoms here. Okay, there are n number of atoms here. So these atoms will also be displaced during this. So if you see, this is a intergranular, this is intragranular. It will flow along the grain structures. Okay. So next, what is the difference between brittle and ductile fractures? Occur with minimum or no deformation. Brittle, no plastic deformation. Occurs with large plastic deformation. Occurs suddenly with minimum energy absorption. Yes, it will not absorb any energy. Whereas it will absorb some energy, it will undergo plastic deformation. After plastic deformation, it will break into two pieces. Now separation occurs normal to the tensile axis, resulting in flat surface, whereas crack propagation in an direction at 45 degrees to tensile axis, resulting in cup and cone formation. Initiates at a point where micro cracks is largest. So it will always start, if one crack is there, brittle material will start automatically breaking with small amount of stress also. Whereas initiates in some localized region where deformation has happened. Wherever the plastic deformation has already formed, in that place the ductile fracture will happen. Okay, movement of the crack involves very little plastic deformation. We can consider it as to be zero plastic deformation, whereas crack propagation as a result of highly localized plastic deformation. So until unless you see some highly plastic deformation, the ductile material will not break, because it is having some still energy stored in the plastic deformation. Now fractured surface shows sharp and planar surface. Sharp means either it will be edge like surface or it will be purely plain surface, whereas the fractured surface appears dirty with a rough contour, because they are attached to one another. While breaking, they still maintain that bond between the atoms. Because of that, the surface obtained because of the ductile fracture will be much rough and it will be dirty. Okay, so commonly observed in BCC and HCP, that is hexagonally closely packed metals, whereas this is commonly observed in face centered cubic structure. In general, fracture occurs along the cleavage planars, whereas it occurs at a 45 degrees to the tensile axis. Whatever is the axis you are having, that is because of this 45 degrees only, most of the time in ductile fracture, cup and cone will be formed. If you can see this, this is the 45 degrees. Okay, once the crack is initiated, it will form a 45 degrees. So this is also 45 degrees, almost 45. So because of this reason only, it will form a cup and cone structure. Fracture occurs along the slip planes. Okay. Now the best example of the ductile to brittle transition is the Titanic ship. So if you have heard about a Titanic ship, you might have listened about Titanic ship. So while making of the Titanic ship, the person who created the Titanic ship, he thought that it will be one of the strongest ship. So during that time, titanium was the one of the strongest element. Basing on its name, he gave the name of that ship as Titanic. That is, from titanium he has taken it as Titanic, which he named it as to be one of the hardest ship. So which has carried a large number of men, almost 5,000 to 7,000 men were there. A large amount of machineries were there. 62 boilers were there. A huge ship was there. So in that ship, why that ship suddenly broke into pieces is the reason behind that is this nature, that is ductile to brittle transition. So until that during 1867 I think and 1913 I think. So during till that time no one known about this nature that ductile material can be converted into a brittle material. So this will abruptly happen only when there is a change in temperature. Okay. So the main reason why the Titanic ship has broken into two pieces is, so when they have thought that the ship will not broke because of its high strength, that is titanium. So suddenly when they are traveling in a cold temperature near to New York, so they have got a bombardment with the ice. So you can think that, sir, ice is not that much strong compared to that of a steel or any material. Okay. So when they have got hit with that during that cold temperature, what happened to that steel is, from ductile it has converted to brittle. So because of that brittle conversion, the hitting with ice led to a small crack initiation in the ship. So they never thought that it will convert to brittle. They thought that it will be a ductile. Because of that, first it will undergo plastic deformation. If you see there is some dent, we can re-edit the dent, we can remove the dent. They thought so. But whereas when the material converted to brittle, as soon as it got hit to a iceberg, so it undergone some fracture, brittle fracture. Because of that fracture, as it has already converted to brittle, the whole material, even one small crack has propagated, and you know that whole ship has gone drown. Okay, whole ship has drawn into the sea. So this was a very, very, very important incident in the whole history of the materials. Till then, no one in the nature has identified that the ductile material will be transited to brittle until this incident happened. After this incident, many scientists were working why this happened, what was the reason behind this. Then they came to know that every material at some particular temperature will convert from ductile to brittle, and brittle will convert from brittle to ductile. There is some transition temperature, especially temperature will play a major role in this. Okay. So this is the reason why we are discussing about this ductile to brittle transition. So the ductile material fracture abruptly and with little plastic deformation. So the crack propagation takes preceding over plastic deformation. In ductile material, generally the crack propagation will take only after the plastic deformation. Until unless there is no plastic deformation, there is no crack propagation. Okay. So but whereas in ductile material, first plastic deformation will happen. Okay. So during what are the terms when the material will change from ductile to brittle is temperature is lowered. The very most important factor, temperature is lowered, rate of straining increased. If you are keep on applying the strain, that is nothing but if you are keep on extending it. So if you are keep on extending it slowly, at some point what will happen means it will convert to brittle. Even we have seen that if you are work hardening the material, so the ductile material will convert to brittle material. Next is notch or stress riser. What is this notch and stress risers is nothing but if there are some cracks inside the material, small holes, especially elliptical holes, that small edges or small cracks will behave as a stress risers. What is the stress risers is nothing but at that point the stress will be easily increasing even you apply a less amount of stress, because of that concentration, it will feel that it can easily break at that point. Okay, so this generally happens, this stress rises generally happens because of some, what we say, unwanted mixing, especially in casting we can see this. So if there are some air bubbles formed, or if some amount of impurities are added, so there it behaves as a stress rises. Okay, so this is the fracture energy, and next is temperature. So initially it was brittle. So if you are applying the temperature, at some temperature, this temperature is called as transition range, where the brittle material will be converted to ductile. Once you crosses this barrier, the material will be completely converted to ductile. Similarly, if you keep on reducing the temperature, at some lower temperature, the material will completely converted to brittle. That's why I told that during the lower temperature, the steel has converted to brittle in during Titanic accident. Okay, so this is the reason. Iceberg means it was almost minus some degrees of temperature. So at that temperature, the steel has converted to brittle. Because of this brittle nature, it has broken. Okay, so till here we are stopping. So next class we will continue from ductile to brittle transition. Thank you.